Question 18. In the diagram, PQ equals PR equals RS, and the angle QPR equals the 40 degrees. Find the size of angle X. Alright, since PQ equals PR, we can see that it is an isosceles triangle. So the equation will be 180 equals 2y plus 40, 140 equals 2y, and y equals 70. So both of these are 70. Now, we want to find angle R. So we'll use 180 minus 70 because it is an angle on a straight line. You get 110. Here is 110. And as you can see, this is also an isosceles triangle. So we will use 180 degrees minus 110, we get 70. 70 divided by 2, you get 35 degrees. So here's 35, and here's 35. Now we want to find angle X. To find this, we use 35 degrees plus 40 degrees equals 75 degrees, and it's on a straight line. So we'll use 180 degrees minus 75 degrees, you get 105 degrees. So the answer for X is 105 degrees. Moving on. Question 19. The average height of 10 trees is 2.6 meters. One of the trees grows from 1.7 meters to 2.2 meters. Calculate the new average height of the 10 trees, giving our answer to 2 decimal places. Okay, so first I will use 2.6m times 10. So this is the total before you divide it by 10. And since one of the trees grows from 1.7m to 2.2m, I want to find the difference first. Difference is 0.5m. So basically, they added 0.5m to the 26m. So there will also be a new average, which is what they want us to calculate. So 26m plus 0.5m, you'll get 26.5m. And you just have to divide it by 10 again, 2.65m. Question 20. Find two whole numbers, which are counting numbers, neither of which has a 0 for any of the digits, whose product is 100. Okay, so to solve this, first, let's start with 5 times 2. 5 times 2 equals 10. So let's try 5 power of 2 plus 2 power of 2. You get 100. So this is the pattern here, and we'll just use this pattern. So 5 power of 2 is 25. 2 power of 2 is 4. So you don't have to try and error for this if you know the pattern. Same thing, there's 6 zeros here, which means it's 1 million. So since there were 2 zeros from 100, we squared 5 and 2. So now there's 6. We will raise 5 to the power of 6 and 2 to the power of 6 too. And if you check, you'll also get 1 million. So 5 raised to the power of 6 is this, and 2 is this. So this will be, sorry, I wrote it wrongly. This will be answers. Question 21. Sarah's bottom drawer contains many pieces of t-shirts, each colored red, white, blue, or black. So there are 4 pieces. There are more than 2 pieces of t-shirts of each color. That means that each color, at least there's 3 of them at least. There are just 2 pieces of t-shirts randomly from the drawer, one at a time, and does not replace them. Write down how many pieces of t-shirt she must draw from the drawer in order to ensure that at least 3 pieces of t-shirts of the same color have been drawn. So we know that there are at least 3 t-shirts for each color. Okay? And let's assume that she has already drawn 2 red, 2 white, 2 blue, and 2 black. That would be 2 times 4, because that's 4 colors, equals 8. And if she draws one more, there will definitely be 3 pieces of t-shirts of the same color already, because she's already drawn 2, 2, 2, 2. If she draws one more, there must be a group of t-shirts that already has 3 pieces of the same color. So 8 plus 1 equals 9. The answer is 9 pieces. Question 22. Find the smallest possible value of 20a plus 10b plus c, where a, b, and c are different positive whole numbers. Okay, so we know that they're going to be different. They're going to be positive, and they're going to be counting numbers. So there's no decimals involved. Now, there we have 3 variables here, a, b, and c. A, b, and c, if you want to find the smallest positive whole numbers, it's going to be 1, 2, and 3. Okay? So these, to get the smallest possible value, we substitute in a will be 1, 10, b will be 2. Okay? So, but if you substitute 2 into a, that would be 40, and it would be 10. And then 40 plus 10, it would be equal to 50. So the smallest possible choice that we can put in is 20 plus 20, which is 40. And then c will just be 3. So 40 plus 3, we get 43. Question 23. In a diagram shown, triangle ABC is isosceles with AC equals BC. So it looks like this. Find the size of angle R in terms of P and Q. So when we're finding angle R, P and Q have to be in the equation. So first I'm going to look at this triangle here. I want to see what should I do to get 180. So first, we're going to look at angle Q. This whole angle is angle R. But of course, we can't just count that because angle Q is here. So we need to get rid of angle Q to just find angle R. So first, we're going to use R minus Q. Okay? And of course, they already give us R. So we're going to add R because we want to find 180. And then there's one more angle that's missing here. And how do we find this angle? Since this is a straight line, we're going to use 180 minus P. All right, now we simplify. This will become 0 degrees equals 2R minus Q minus P. Now we isolate them. R equals P plus Q. Now we want to isolate R. R equals P plus Q divided by 2. So that's how you find angle R. Question 24. I went to a store and picked up 4 items. The cost of 3 of them, okay, 3 of them was 1.5, 3, and 4. I was a bit bored whilst I was waiting at the checkout and happened to notice that the sum of the prices of prices of all 4 items was the same as the product of the prices of all 4 items. Calculate how much the 4th item costs. Okay, so first, we are going to find the sum of 3 of the items first. You get 8.50. So you'll write it as 8.50 plus x. And then we're going to find the product of the 3 items. So, sorry, this is times 3 times 4. You will get 18. So let's set up the equation. Goes 18 times x. And this will equal to plus x equals 18x. and then we're going to move x over here. That will become like this. This will become 17x. And we want to find x, you're going to divide, you get 0.5 cents. So this is the answer.